Hi. In this video, I'm going to go over the Intro to Forces physics journal. So it's pretty short. There isn't an example problem, so it's just the question and the big idea, and then that's it. So let's take a look at our question. So in physics terms, what can a push do? So we were just talking about, like well, never mind. Yeah, what can a push do? So the big idea is consider a bowling ball on a flat frictionless surface. So this is getting at that bowling ball lab that we did, and where you were like looking at the motion of the bowling ball as it was pushed with a broom. So um, if your desired motion is to get the ball to speed up, so we'll call that a positive acceleration. You need to push the ball in the direction of the motion. So if the ball is moving to the right, you need to push it to the right, and we'll call that a forward push, right? So basically the push is in the same direction as the ball. If you want it to slow down, we'll call that a negative acceleration. Again, this is kind of assuming that the ball is moving in the positive direction, but we have a negative acceleration. Then you're going to push the ball in the opposite direction of motion, so a backward push. If you want it to go around a corner, so you want it to turn a corner like this or something like that. Um, well, that's called centripetal acceleration, and we might talk about that later. But you push a ball on the ball perpendicular to the motion. So if your ball is right here, you're going to apply a push perpendicular to it, so at a 90-degree angle to the motion that the ball is going. So I called that an inward push. So an inward towards like the center of the curve, right? So if it's making like this left-hand corner, you're giving a push towards the middle of the radius of the circle that it's going around. If you would like to go at a straight line at a steady speed, so you don't want it to speed up, you don't want it to slow down, you apply no push. Now the reason you might think, oh, like why would I put this here? It might seem fairly obvious. However, right, a lot of people think that in order to get, I mean, like, okay, it might seem like, okay, if I don't push it, obviously it goes in a straight line. And you might even think, oh, it's going to go at a steady speed, but a lot of people think that right, there is like basically a required force to continue to get something to go at a constant speed. Like to get something to go at a constant speed, you need to have a force to get it to do that. You need to be applying a force. And that comes from generally thinking about wind resistance, right? In real life, you have a lot of wind resistance and like as you drive down the freeway or whatever. And so obviously your car needs to keep driving even though or keep going even though you're going at a constant 60 miles an hour. Well, the reason that that is the case is because there's a force resisting you, or there's friction resisting you or something like that. But if there's not really a force of friction, like this case of the bowling ball rolling across the floor, then you don't need a push to keep it going at a constant speed. Okay, so so if there's no resistance force, then you do not need a force to keep it going at a constant speed. And then lastly, we've kind of covered this already, but a push or a pull is called a force, and a push or a pull that causes an object to speed up or slow down is called a net force. Again, the word net there just kind of means total. So those are kind of some two definitions for you. Okay, well, thank you for watching. Bye.